All right, in this problem, what I want to do is resolve this 100-pound force along two different sets of directions. First, I want to do the traditional XY direction. You should be familiar with this coordinate system if you've ever taken an algebra class, and we know that this X direction and this Y direction are going to be 90 degrees from each other. So they're perpendicular to each other. The second set of directions I want to resolve this 100-pound force along is this X prime Y direction. Now the X prime direction is 30 degrees under the X direction. So let's start with the regular XY coordinate system. And what we're going to do is we're going to draw in the X and the Y coordinates. So right here, this is going to be Y, this is going to be X. And I also want to make these lines dotted so I don't confuse my coordinate system with vectors that I'll be putting on it. Okay, so now I have my coordinate system. Let's put in our 100-pound vector. So this is going to be 100 pounds, and this makes a 40-degree angle with the x-axis. Now, how do I get my x component and my y component? What I need to do is I need to put my pen on the tip of this resultant vector, and I need to, if I'm going, let's do the x direction first. I'm going to draw a parallel line to x, and where it intercepts with the y axis, I stop. So that becomes right here my fx, so my component of this force in the x direction. And we're going to do the same thing with y. So we're going to put our pen here, draw a line down, and this green line is parallel to the y-axis, so this becomes my component of the force along the y direction. I'll call that Fy. Now we know with vectors I can rearrange them like so. So this right here is going to be Fy, and when I do this I create a parallelogram. And I can check this. Fx plus Fy gives me my resultant. Fy plus Fx also gives me my resultant. But how do I figure out the numerical value for Fx and Fy? What I'm going to do is draw half of this parallelogram. And this is a special case of the parallelogram. With this coordinate system, when they're 90 degrees apart from each other, the parallelogram is going to be a rectangle. And when we have a rectangle and we draw half of it, we're going to get a right triangle. So right here, when I redraw this, so this will be my 100. I'm going to have Fy right here. And I'm going to have Fx right here. I need to solve this triangle, and because it's a right triangle, I can use SOHCAHTOA. Now remember, you can only use SOHCAHTOA if it's a right triangle. You can't use it for any other case. It will not work. Now, how do you use SOHCAHTOA? Well, we break it up in groups of 3. So this, and this. This is the sine, is the opposite over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse, and the tangent of the angle is equal to the opposite over the adjacent. Because this is the angle, this 40 degrees is the angle we're working with, Fx right here becomes our adjacent, Fy right here becomes our opposite, it's opposite from our angle, and 100 right here is our hypotenuse. So now let's match up what we have with SOHCAHTOA. Let's do f of x first. When we do f of x, what do we have? So it's a. We know we have h, so a and h is going to give us the cosine. So this means the cosine of 40 degrees is equal to the adjacent, so f of x, over our hypotenuse, which is 100. So we can solve for f of x. We can multiply this side by the cosine. So we get 100 times the cosine of 40. And make sure your calculator is in degrees here. And when you do that, you're going to get f of x. And this is going to be equal to 76.4 pounds. We can do the same thing with this f of y. So when we do this, y is our opposite. We still know our hypotenuse. So opposite and hypotenuse is our sine. So for Fy, let's start with the entire equation. So the sine of 40 is equal to Fy over 100. Solve for Fy, multiply both sides by 100, and we get 100 times the sine of 40 is equal to Fy. And again, make sure, be absolutely sure that you're doing the sine of 40 degrees and not the sine of 40 radians. And this is going to get us 64.3 pounds, approximately. So this right here is the resultant, our y component, and this one up here, our f of x, is our x component, and that's our answer. So that's what the magnitude of that resultant along the x is. Now, right triangles are very nice. We can use SOHCAHTOA. When you do enough of these problems, you won't need to dissect SOHCAHTOA as much. You'll just know if this is my angle and I'm looking for this length of my angle, I'm always going to use cosine. If I'm using this part of my angle, I'm always going to use sine. So you can just use the hypotenuse times the sine of the angle, and you don't need to dissect and derive SOHCAHTOA every time. Now let's look at what we want to do if we want to resolve this along this x prime y axis. Again, the first step is drawing in the axes that we're looking at. So right here is going to be x prime. Right here is going to be y. And again, let's make this a dotted line so we don't get confused. And draw in that 100-pound force. Now, let's make sure we know what our angles are. Right here, this is my original x-axis, and this is 40 degrees. This is 30 degrees. So this entire angle right in here is going to be 40 plus 30, or 70 degrees. We're going to use the same step. Let me make this just a little bit shorter so I can fit the whole vector, but we're going to use the same steps that we did before. We're going to put our pen on the tip of the vector, and we're going to draw a parallel line with the x-axis, and we're going to stop when we intersect with that y-axis. So this right here is our f of x, and we're going towards the resultant. Let's do the same thing with the y. So we're going to start right here. We're going to draw a parallel line with the y, and this right here is our force of y. And let's be careful. Right here, let's call this f of x prime, so we don't confuse it with our regular x-axis. All right, so now what? Well, this is not going to be a right triangle. We can make this our f of x, so this is also f of x. We can make this one right here f of y. And let's draw one of these triangles. Let's draw this one right here. So when we draw this triangle, this is my 100. I know this one right up here is going to be f of y. And this is going to be f of x. Now, what are the rest of our angles? This in here is 70 degrees. Can we figure out what the rest of the angles are? Well, we could. If we know this was 40 degrees, or this was 30 degrees, if we draw a line at the x-axis, we know this needs to be 90 degrees. So this right here needs to be 60 degrees. So this angle right in here is 60 degrees. 70 plus 60 is 130. 180 minus 130 is going to be 50. So now we know all of the angles of this internal triangle. This line right here was our original x-axis, and we were given information about those angles. Now, since we know all of these angles, we know all three angles, we're allowed to use the law of sines. And when we look at the law of sines, let's remember what that is. We have some triangle right here, and we have three sides, A, B, and C. The sides opposite of A is going to be alpha, side opposite of B is going to be beta, and the side opposite of C is going to be gamma. So the law of sines says that A over the sine of alpha is equal to B over the sine of beta, which is equal to C over the sine of gamma. Now, doesn't matter which side we call A, B, and C, but we're going to have to use this 100 pounds. So the 100 pounds is going to be 100 over the sine of the angle that's across from it, so 60. And this is going to be equal to, let's look for fx first. So fx prime over the sine of what? Across from f of x is 50 degrees. Now we can cross multiply, so we're going to get f of x prime is equal to 100. Actually, let's just cross multiply. So f of x prime times the sine of 60 is equal to 100 times the sine of 50. Let's divide out by the sine of 60. So we get f of x prime is equal to 88.5 pounds. Now we're going to do the same thing with fy. Now I tend to like using this again in case I had made a mistake when I'm calculating f of x. But when I do this, I'm going to get f of y over the sine of what's over y. So y is across from 70. So over the sine of 70 is equal to 100 over the sine of 60. And again, if we cross multiply, we're going to get fy times the sine of 60 is equal to 100 times the sine of 70. Divide by the sine of 60. And what we'll get is we'll get that fy in this case is going to be equal to 108.5 pounds. So this becomes the answers if you're resolving this along this x prime y coordinate system.